Hello, my fellow friends. Yesterday we learned how to work with the calculator for trigonometric values. Now we're going to learn about the trigonometric formulas. There are two formulas, and the first one is the relationship between the sine, the cosine, and the tangent. I'm going to show this. It is quite easy. So, in this triangle, if we would take the sine of b, we know that the sine is opposite over hypotenuse. So in this case, this would be b divided by a, or 3 divided by 5. For the cosine, we know that it is adjacent divided by hypotenuse, so it is c divided by a, or 4 divided by 5. Now, in the third row, what if we would divide the sine of b by the cosine of b? So we're going to divide b divided by a divided by c divided by a. Now you notice that both numerator and denominator are divided by a, so we can simply leave that out. And we have b divided by c, or in other words, 3 divided by 4. Now tangent b, we know, is opposite over adjacent, b divided by c as well, and also 3 divided by 4. That's why we're going to conclude on the next page that the tangent of an acute angle in a right-angled triangle is equal to the quotient of the sine and the cosine. So here is that formula. Yes. Of course, this is also going to apply on the other acute angle in that right-angled triangle. Here is a clarification. That clarification isn't very difficult. It's almost more or less the same as I've just done in the small research. Look, we know that the sine of b in general here is b divided by a, and the cosine of b we know is adjacent divided by hypotenuse, so c divided by a. If we do sine b divided by cosine b, you get b divided by a, c divided by a. The a's, we can leave them out because you're going to divide both numerator and denominator. That's how we get to b divided by c, and that's how you go to tangent b. Yes? This is something that you're going to do on your own. You're going to use your calculator to calculate the sine, the cosine, this value, and this value. Later on, you're going to take a picture of that and you're going to place that in the upload zone. That was the first formula. The second formula. For the second formula, I'm going to do a small research as well. First, I'm going to take a look at the sine of b. So the sine of b is opposite divided by hypotenuse, so 3 divided by 5. Cosine b is adjacent divided by hypotenuse, so 4 divided by 5. Now, the question here is, what if we square the sine of b? So sine of b, which is 3/5, squared would equal 9 divided by 25. If you are going to square the cosine, which is 4/5, you get 16 divided by 25. Final step. What if we would add these two values? If you're going to add these two values, you're going to notice that they equal to 1. So our conclusion: Our conclusion is that apparently the sine squared of b plus the cosine squared of b is equal to 1. As I mentioned to you yesterday, I'm going to say that one more time. Sine squared b is equal to sine of b squared, of course. But we're going to write the square, the little 2, we're going to write it over here, because if you would write it over here, it's very likely that you're going to square the angle and not the sine. Now, this is my very important formula. It's the base formula of trigonometry, and we're going to prove this formula on the next page. Don't be afraid, it's not a very difficult proof. It is quite straightforward. So, this is true. The sine squared of an acute angle plus its cosine squared equals 1. It's also true for the other acute angle, of course. Now we're going to prove that. We have our right-angled triangle, right-angled in A, so A equals 90 degrees. And we're going to prove these two things. Well, we start with our famous Pythagorean theorem. The Pythagorean theorem says that hypotenuse squared is equal to the sum of the squares of the two right-angled sides. Now, because of this being an equation, you can always do some conversions to this on both sides of the equation. Dus je kan een bewerking doen, linkerlid en rechterlid, dat verandert niks aan je uitkomst. I'm going to do divide both parts by a squared. So I'm going to divide everything by a squared. Yes. Now, b squared divided by a squared, I could also write this as b divided by a between parentheses squared. Same thing for c divided by a. And this, of course, is the exact same thing, so that equals up to 1. Now, b divided by a, to angle b, that is the sine opposite divided by hypotenuse, that is the sine of b. C divided by A is to be adjacent divided by hypotenuse, so that is the cosine of B. But of course, I could also take a look from a point of view C. To C, B divided by A is the cosine of C, and C divided by A is its sine. Now, this is almost a proof. We know that sine A squared equals sine squared of A. So we're going to write it on both sides like this. And now simply I'm going to switch these because of the addition being commutative. And that's the proof. Yeah? Don't think that is very difficult. Now I'm going to continue to this. And I'm going to give you one example exercise. First, you're going to do this, and you can do that on your own. So simply verify if the sine squared of 70 is equal to the plus the cosine squared of 70 is equal to 1, and also for another angle. It's a good exercise or a good practice to use the calculator. Now, what can we do with these two formulas? And this is very important. These two formulas are going to help me to determine the trig ratios if another trig ratio is given without using a calculator. Yes? So at first we have the cosine of b. I'm going to use this formula, sine squared of b plus cosine squared of b equals 1. This is an equation. I know the cosine of b, so I'm going to isolate sine of b. So I'm going to do this, sine squared of b equals 1 minus cosine squared of b. Sine squared, I don't need the sine squared, I want the sine of b, so I'm going to extract the root out of 1 minus cosine squared of b. I know cosine b. Cosine b is 0.5, or you could write that as a fraction as well. 1 second squared. So square root of 1 minus 1/4. Or square root 1 we know is 4/4 minus 1. So we have 3 divided by 4, or you get square root 3 divided by 2. That is the sine of b. Well, now if I have my sine, it's going to be quite easy to calculate the tangent, because we know that the tangent of b is equal to the sine of b divided by the cosine of b. So sine of b we just calculated is square root 3 divided by 2. Cosine is 1 divided by 2. Same thing. Or you could do it like this, square root 3 divided by 2 times, if you're going to divide a fraction, you're going to multiply the first fraction with the reciprocal of the second one. So therefore, the 2's are gone. And now we have tangent b being square root 3. Yes? Okay. With this example in mind, you are now going to try and make exercises 10 and 11, and you're going to upload them later on in the upload zone. Okay, good luck. See you tomorrow.